This is a vodcast about vector lines, and we're going to talk about lines in the 2D plane. And I'm going to start off with an algebra example using this point slope version of a line. So I have the line y minus 3 equals negative 2/5 x minus 4, which, if you recall, means I'm going to start at the point 4, comma 3, which is point A in this picture. And then the slope is what tells me in which direction to go and how to get to other points. And if as long as I go in the ratio down 2 over 5 or up 2 and to the left 5, or I could go down 1 and over 2.5, things like that. But that negative 2/5 is giving me a sense of direction from point A. Well, vector lines are very much like that. But instead of expressing the direction as slope, we're going to express it like we've been doing as a direction given by a vector. So let's see how we could describe this line that goes through points A and B using vectors. Well, let's see. How do I get to points on that line? First, I could go out to point A along this red vector. Okay, that takes me to point A, and that's where I'm going to start. And then I could travel along there. Let's say I wanted to get a point B. I would go from A to B. Okay, and that's this blue vector. And that looks like vector addition of, let me move this. That looks like that vector addition. That, what I've got so far, is vector A plus vector AB. Here's vector AB. We're going to leave that T over there for a minute. And I'm going to call this vector, I'm going to call this vector, this purple vector, R for right now. So that is vector R is equal to vector A. Get out to point A and then travel in that. Well, we know how to find all that stuff. Vector AB is the displacement vector from point A to point B, which is vector B minus vector A. And we find that by doing 9 minus 4 I plus 1 minus 3 J, which is 5I minus 2J. And you might notice that those numbers 5 and negative 2 are the exact same numbers that we had in the slope. So that's a really similar idea as a vector way of talking about slope. Okay, well that just takes me to, from the point, that means that the point 9, 1 would be on, if I do A, vector A plus 5I minus 2J, that would take me out to the point 9, 1. But I want to just get out to any random point. So I want to change this a little bit. And let's say I want to get to that point there. Now I'm going to look at that. My picture is going to change a little bit. I don't necessarily always want to go to the point 9, 1. I might want to go to some other point. So, but that is some scalar value times that vector AB, because the AB is giving me the direction. I'm trying to get these guys together here. Oh, well, there we go. So some number T times vector AB is going to take me to this any point on the line that goes through points A and B. So now my R looks like this. R is equal to vector A, that takes me out to point A, plus T times vector AB, which sends me in the direction of B, but might not take me all the way to B. If T is negative, it could take me in the opposite direction, but it is going to be on that line as shown in that picture. So all we have to do now is write this in component form. So vector R is equal to 4i plus 3j. That's the position vector that takes me out to point A, plus t times 5i minus 2j. That is the vector that's going to take me in the direction of from point A to point B. We can combine this in a couple of different ways. So let's rewrite this as 4i plus t times 5i. I'm just combining terms now. 3j plus or minus t times 2j. And if I combine the terms in a little bit different way, get the i's out of there, I have 4 plus 5ti plus 3 minus 2tj. This is r. So we talk about the parameters. We can talk about the parametric form of the point xy. The x, as in terms of t, is equal to this 4 plus 5t. Y of t is equal to 3 minus 2t. Okay, and that's the parametric form of this line. If I put in different values for t, I will get different points on that line. Okay, end of the first part of this two-part podcast.